tablets in a new facility. It has the capability to produce 10 million tablets per week, as well as capsules and other products. It will do so with only 2 or 3 employees working in 340 square meters of production space. For the employees at Alcalá de Henares, the problems of chemical exposure have been eliminated, and the risk of contaminating the product has been greatly diminished. Worker satisfaction is high, quality control is high, productivity far exceeds that of conventional operations, and costs have been reduced. To talk about these accomplishments is the Director of Manufacturing Services in Continental Europe, Willy Lewest.
Does this sound too good to be true? Well, it's not only possible, it's happening. In the next few minutes, we'll demonstrate how it's done. You will see how these improvements have resulted from ingenious and fascinating pieces of equipment designed specifically to streamline those areas of pharmaceutical production that have been most wasteful in terms of time, efforts, and space. Let me explain. Improvements in pharmaceutical equipment in recent years has been impressive, but the handling of materials between these machines has remained virtually unchanged. The new equipment and plant design at Alcalá has dramatically changed all this. Before I get to that, let me give you a brief overview of the plant and show you how we are saving time and money. On this model, what we are looking at, in fact, is the ground floor of the Alcalá facility. Workers coming in would enter through that changing room and find the granulation equipment, which is a regular fluid bed dryer. Over here, we have a capsule filling machine. In the next cabinet, you find a sieve, then a rotary press, and finally, a film coating pan with the containers for the required solutions. People working in this area use this main corridor, while on the back in here, we have the technical corridor, which in fact contains all the services for the various machines and for the air conditioning. Now, the main difference between this facility and what is found in a regular pharmaceutical plant is that you don't find any room for storing pallets, drums, bags, raw material in general, granules or finished products. Consequently, you don't find any traffic space either for forklifts, trolleys, and similar equipment. This is what the ground floor actually looks like. Using this model, you can see that the new facilities in Alcalá are 3 stories high. The process begins up here on the 3rd level. Raw materials are weighed and dropped into a flow-bin container on the 2nd level. This container is moved through all production steps by a transfer car. The transfer car receives its orders from an operator using a control panel. The flow bin is moved to various stations directly above the process equipment on the ground floor, like for instance a rotary press. The material is dumped on that press just by gravity, and after tableting, the product is sucked back by vacuum into an empty container on the floor above. From there, the transfer car will pick that container again and move it to the next manufacturing step, which could be a film coating operation. This sequence is a significant change from conventional production, and it repeats all the way from granulation to final tablet coating. The same process is also used for capsule filling. There is no human contact except for periodic inspection and no chance of cross-contamination. Now, let's see what it looks like in operation. As I said, the process begins on the 3rd level, where raw materials from the warehouse enter a dedusting chamber. Jets of air blow any dust from the container surfaces. After that, the raw materials are weighed and put into this chute, which connects with a flow bin on the floor below. A second scale double checks the weight of the material and shows the total weight as the materials accumulate in the flow bin. The flow bin into which the chemicals have just been placed is one of the pieces of equipment that has revolutionized production at this plant. It is basically a large container with some special features. Each flow bin is approximately 1.4 meters high by 1.2 meters wide and weighs about 250 kilograms when empty. Each flow bin is designed to contain one full batch of materials. These containers are on the second floor of the building. After the operator on the third floor is finished loading the flow bin on the floor beneath him, the flow bin is moved to a workstation where a process is completed, then to another workstation, as I said before. For example, when the material in the flow bin is ready for granulation, the flow bin is moved to the fluid bed granulator. The two pieces of equipment are tightly sealed together so that there is no loss of material and no contamination of the environment. Once the flow bin is in position, the material is released into the granulator on the floor below. The material transfer from flow bin to granulator does not require any contact with employees or with outside air. After granulation is complete, the material is sucked back into the flow bin by vacuum, again without any contact with the outside environment or with employees. The flow bin is then moved to the next station where lubricants are added. Then it is moved to the tumbler where the granules are completely mixed. This type of tumbler permits the contents to be mixed without taking them out of the flow bin container. After tumbling, the flow bin is moved to the next station, in this case above the rotary press. Once in position, it drops the granules directly onto the machine on the floor below. While the material is compressed into tablets, sensors detect when to turn on the vacuum and the tablets are sucked back into the flow bin. When the batch is completed, the flow bin is moved to the next workstation, tablet coating. Then the material is fed by gravity into the film coating pan on the floor below. It is vacuumed back up after the batch has been coated. The vacuum feeders that load the flow bin from the floor below after each process are stationary. There you have it, a system that has addressed itself to the most wasteful steps of pharmaceutical production and come up with what we think is a substantial improvement. It is productive, it's efficient, it's clean, it is safe, it is everything a pharmaceutical manufacturing operation should be. As far as product integrity, quality control, and safety to employees are concerned, it comes closer to the ideal than any previous system. And it does so in a way that saves space, time, and money. And if you will pardon me a frivolous comment, it's a lot of fun to watch.